So the other day we learned the remainder theorem, which says if you're dividing by, let's say you have x cubed plus x squared plus 6, and you're dividing by x minus 1. The remainder theorem says you can plug in 1 into this, so that would be 1 plus 6, and you'd get 8. When you plug in 1, you get 8, and 8 is the remainder when you would divide x cubed plus x squared plus 6 by x minus 1. So the remainder theorem says if this is my polynomial p of x, and I'm dividing by x minus 1, I switch the sign, plug in p of 1, and whatever number I get is my remainder. Now, the factor theorem basically says the same thing as the remainder theorem, just as more specific. If whatever you plug in happens to equal 0, then you know, since the remainder is 0, then that must be a factor. So we can use that factor theorem in this example here to figure out which of the following are factors of this. So in other words, we want to find out which ones of these have a remainder of 0. And if they have a remainder of 0, then we'll know that they're a factor. So we have two strategies that we can use to figure out the remainder. We can use the remainder theorem, or, well, we have three strategies actually. We can use the remainder theorem, we can use synthetic division, or we can use long division. Now that you've seen synthetic division, most of you would probably choose synthetic division over long division just because it's that much quicker. So for this first one, I'm going to use the remainder theorem. I'm going to call this polynomial p of x. And in order to find out if x plus 1 is a factor, I'm going to figure out what p of negative 1 equals. That means I'm going to plug in negative 1 for x. A negative 1 cubed is going to be negative 1 minus 6, because negative 1 squared stays positive 1, minus 5 plus 12. And sure enough, it's equal to 0. So we can say since the remainder is 0, we know that x plus 1 is a factor. I find if you're dividing by x plus 1 or x minus 1, the remainder theorem is really quick to use because it's easy to do 1 cubed in your head or minus 1 cubed in your head. But in part B, C, and D, when you get to those bigger numbers, like not even that big, but 3 or 4 or even 2, the mental math is going to be easier if you use synthetic division. So for B, with x minus 3, if I set up synthetic division, 1, negative 6, 5, 12, again, you have to make sure that those are written in the right order, and they are, and that none of them are missing. Because if there is a power of x missing, you have to put in a 0. One way to check that none of them are missing, see that my highest power is x cubed, power is 3, then there should be 4 things in synthetic division. If your highest power was a 5, you would have 6 constants written in synthetic division. Because you have all the powers 1, 2, 3, 4, 5, plus the constant makes 6. We put the opposite sign out here, and then we can begin our synthetic division. And once again, we get a remainder of 0. So we know that x minus 3 is a factor as well. In C, we are checking x minus 4. So once again, I'll set up the synthetic division. Positive 4 out here. Bring down the 1. And we found another one. X minus 4 is also a factor. And synthetic division for the last one, we're checking x plus 4. We have a remainder of negative 168. Yes?
So, can you use the first method or synthetic division interchangeably
To find the remainder, yes. So you can use either remainder theorem or synthetic division to find it out. But you're going to find, okay, I know that a lot of students go, oh, I like synthetic division better, so I'm not even going to worry about the remainder theorem. But there are some questions that one method will be better than the others, and I'm going to show you some of those. So you do need to know both methods, and then have to make your decision when you get to the question, what do you think is going to be the better method? Yes?
Did you just realize since the x minus 4 worked, and it's the exact same numbers that the x plus 4 would not work?
There will be some cases where an x minus 4 and an x plus 4 would both work. But with the same numbers. So I could make a polynomial where x minus 4 and x plus 4 were both factors. In this case, x plus 4 is not a factor. Now there's a couple of ways we could have known already that x plus 4 was not going to be a factor. Because if we write out our original function, which is x cubed minus 6x squared plus 5x plus 12, we have factored this. In fact, we've factored it completely because we found out that x plus 1 is a factor, x minus 3 is a factor, and x minus 4 is a factor. And if you have something to the power 3, you can have at most 3 factors. Just like when you were factoring quadratics, x squared equations, you would have 2 factors because it's a power of 2. If you had something that was an x to the 5, you could have up to 5 factors. But you can't have more than that. Because when we multiply this out, this x gets multiplied by this x gets multiplied by this x. That will give you that x cubed to start with. If you had another factor, you would have an x to the 4. So once we had found a, b, and c, that those were the 3 factors, we were basically done because there couldn't be any more. Now, what's going to happen is you're going to get questions, and we're going to do one this afternoon that says, factor this fully, and give you no hints to start off with. So then you're going to have to try to find one that works. And the way that this is going to work out nicely, and I'm going to do it, I'm just going to write out what we discovered with this one in part C. So if I wrote the division statement after doing part C, part C, you find out that x minus 4 is a factor. So this is equal to x minus 4, and this was the answer after synthetic division, x squared minus 2x minus 3. And once you find one factor and you write the division statement, right, and the division statement is polynomial, divisor, quotient, plus remainder, but there is no remainder because the remainder is 0. Once you've written your division statement, you end up with a quadratic. And that you can factor. Because you know, well, I have an x minus 4 out in front, but this is x and x, 2 numbers to get 3 is 3 and 1. The 3 has to be negative, the 1 has to be positive. And we get the same set of 3 factors that we have at the bottom. And you'll find out if you would have done the same thing after B, it would have worked out to the same thing, or the same thing after A. But A, because we use this, you would still need to do synthetic division with part A in order to find out what your division statement would be. And then you can factor completely. Yes? It would, well, if you look at question 3 that we're going to do this afternoon, it basically takes this out and just says factor fully. So then you have to be able to take this polynomial that you start with. They wouldn't give you any hints. And you have to find one that has a remainder of 0 and then go from there. So this afternoon we're going to look at some strategies for how can we find those. No, we'll have x to the 4, x to the 5 ones. With an x cubed one, you'll get, an x to the 4 one. After finding 1, you'll be left with an x to the 3. And then you have to do the process again and find another one. And then you get to your quadratic, which you can use your shorter way of factoring. So right now, there's 2 questions, 10a and 12. But I want you to work on 12 right now for the last 5 minutes.